Welcome to Syntax. Today, we're going to be talking to Ivo Plaza about TypeGPU and all of the amazing things you can do with it. So we're here at JS Nation, myself, CJ. Welcome,
Hello.
CJ.
What's up?
And Ivo, we found him, just got off stage here, so we figured we would chat about TypeGPU.
Thank you so much for having me. Yeah, this is
Yeah.
amazing. Long time watcher of the podcast. Yeah.
He mentioned he roots for me in CSS battles.
Oh,
Yes.
yeah, okay.
He's a CJ bot in the comments.
CJ bot in the comments, man. Yeah, so let's start with TypeGPU, which is something that came onto my radar recently. I made a video about it. And can you just give the audience a little bit of high level, what is TypeGPU, how it came about?
Well, I feel like we're in this new kind of era on the web. Like for a while, all we could do was WebGL and graphics, and Three.js is the main like library player. But I feel like now we have a very good opportunity to try a different direction, try something new for TypeScript enthusiasts. And that's what TypeGPU is. TypeGPU is a wrapper around WebGPU, which is an upcoming web standard, which is almost supported in every browser. Linux is lagging behind, but hopefully next year. And it gives you very low-level access to your GPU while still having that TypeScript developer experience. And our main frontier right now is allowing you to write shaders in JavaScript, which normally what you have to do is you have to write them in a special language called WebGPU shading language, which might not be super accessible for existing JavaScript developers. So we want to just make that easier.
Yeah, I found the shader language to be very tough to pick up, especially for like somebody who's used to programming in JavaScript. You're always thinking about looping in regards to executing this, then this, then this. But with shaders, you're executing tasks on every single pixel at once when you're doing graphics. Is that still the case with TypeGPU and how you, man, that is a weird way to like shift your brain.
Yes.
Have you worked a lot with WebGPU before embarking on this, or graphics programming in general?
Yeah, I mean, my first experience with programming was C++ and OpenGL a while back.
Yeah.
And I only got into JS because they didn't have C++ compilers on my school computer. So now I'm here. Now I'm writing in JS.
Have you ever built a visualizer for, what is it?
Like Winamp?
Yeah, like a Winamp visualizer, yes.
Oh, I wish.
Yeah.
I wish. It would have been amazing. Mostly like game development with OpenGL and C++. And I mean, that was always amazing, but I feel like JavaScript is a really amazing platform, and the browser in general for creating experiences that you can just share very quickly with people. I was always frustrated that, I was building on my local machine, but if I wanted to share it with a friend that has a Mac, I couldn't do it. I would have to buy a Mac, and that just wasn't in my budget on my $0 budget. So I feel like the web opens that up a lot, and I'm thankful that I get to use this experience at work and working in open source full time. I've been working a little bit with WebGPU before. And TypeGPU is mainly the result of my frustration with WebGPU.
Dude, it is
because
tough.
it's super powerful, but it's very low level. If you want to communicate with WebGPU, it's essentially like you're trying to talk to a server, but the only way to talk to it is to send instructions to it in a different language and send a binary to it. You can't send like even numeric values, like you have to package them up as a float-free to array and send it over. If you want to do more complex structures, you have to think about padding in memory, how the GPU is going to interpret that, what the padding rules are. And if you get that wrong, well, you get a wrong pixel, and good luck trying to debug that. So that was our first frontier, just making that connection between the shader and JS easier. And we do that through Zod-like schemas.
Yeah.
So we're very inspired by libraries like Zod, like Valleybot, Archetype, where you define the schema once and you get both the type safety and the runtime checks. And we do a similar thing, but instead of runtime checking and validating the object, we use it to serialize and deserialize plain old JavaScript objects, arrays, and primitives. And what that allows us to do is you have a single source of truth that generates both the WebGL shader code and allows you to send and download the arbitrary data from the GPU. And that was our first frontier. We finished that up about a year ago. And since then, we've been pushing that forward to allowing you to write shaders in JavaScript, where now, thanks to that integration, you can write your shader and refer to something that lives on the CPU. And then you just have that connection both at runtime and on the type level. And that was very, very important for us. And I feel like it unlocks a lot of possibilities, similarly to how tRPC and SvelteKit allow you to run your function on the server without having to worry about REST APIs and stuff like that. You can now just call a shader function without having to set all of that glue up yourself.
Yeah. Can we talk a bit about how that actually works? Because I mean, so like if you look, first of all, go check out the docs. The
docs are
TypeScript,
great.
really good docs,
really good.
But you're writing code that just looks like TypeScript, and I don't know if I've seen a library like this before, where you're writing TypeScript code, but there's this little use GPU directive, and at the end of the day, your code actually gets run through a compiler. Like you wrote a compiler that takes your code that looks like TypeScript and actually turns it into shader code or like WebGPU code.
Yes.
So yeah, can you talk a bit about how that works? And so in your talk, great talk by the way, you had an analogy of like front end versus back end. There's typically like this translation layer of like a tRPC or even like SvelteKit with like remote functions. And you mentioned that this TypeGPU library is kind of like that for the CPU and the GPU. It's like it makes it much easier to write code that communicates between the two. Can you talk a bit about that and how this all works?
Yeah, of course. I mean, I feel like the serialization and the type safety is a bit easier to explain and start from. The code structure, I mean, how you would approach it normally is just a lot of TypeScript generic magic. But essentially, if you we have a couple of built-in primitives that we just export, and we know the types of them. And if you use them in our APIs, we're able to extract the information about what you're trying to use. So it's essentially equivalent to having like multiple overloads over a function, and we choose behavior based on that. But the more complex data structures, like structs that define shapes of objects or arrays, they're just basically a bit more complex in terms of the TypeScript types. So we just go over the fields that you defined in the schema, and we save that on the type level so that when you refer to that same struct, we're able to properly change up the API and react to it. I mean, like TypeScript is Turing complete on the type level. So you can technically do anything, even run Doom, of course. But it like as far as TypeScript magic goes, between defining type annotations and Doom, we're still like pretty close to here, not doing super advanced stuff on the type inference front. But yeah, that's essentially how it works. And afterwards, I mean, since you can just access those objects in JS, if you write your shaders in JS, you also have access to that. And the types naturally flow from your CPU code to your GPU code, since you can import stuff from other JS files, and the types propagate naturally thanks to it being in the same language. So we don't even have to like write our own custom language server, because since it's just TypeScript and it's semantically correct TypeScript, we can leverage existing tooling and hook into your existing bundler, thanks to Unplugin, the UnJS ecosystem. Thank you to Daniel Rowe. We're able to create a single transformation plugin that looks at your JavaScript and tweaks it a bit so that it works. I can talk about it later if you guys want, but we're able to target pretty much every bundler on the planet thanks to the work of the UnJS team and Unplugin. I don't know if you guys are familiar with the project, but yeah, it's an amazing piece of tech. And if you guys think that you want to build something, first look at the UnJS website. Nice. You're most likely going to find it there.
It's cool. Yeah.
It's amazing. But yeah, we basically look at your JavaScript source code. We look for functions that are marked with the use GPU directive, and we attach metadata to it so that at runtime we can associate a function with the metadata that we can use for generating the shader code. So the actual build step is quite simple to showcase and to explain, at least like visually, what the code actually turns into. You could think that we replace the JavaScript functions with the shader code, but that's not actually what happens. To keep it flexible, and to allow the shaders to react to the user's settings or your settings as the developer, or as I showcased in my talk, being able to accept callbacks from the user to inject into your shader code. We do have to defer shader code generation to runtime. You can do that at build time if you use another Unplugin gem or Unjs gem, which is called Unplugin macros. I really recommend that as well. It's like bun macros, but for anything. But what we do is we extract the abstract syntax tree of the function that you marked with use GPU. We turn it into a very compressed format that we call TinyEST, which stands for TinyEST, like tiny embeddable syntax tree. But we figured out that name just for the sake of reserving that name on NPM. So we inject that metadata into the user's JS bundle, and then at runtime, whenever somebody gives us their function, I mean the TypeGPU API, whenever somebody says, hey, TypeGPU generate a shader for this function, we're able to see, okay, did you associate metadata with this function? Okay, cool. Let me extract that metadata. And then based on that, we generate the shader code. The details of like how we traverse the tree and generate wiggle from it, it's going to be in my talk, hopefully on YouTube someday soon. It's definitely like a complex process, but thankfully, like at the end of the day, the code that you write is pretty similar to the code that ends up on the other end. And we really wanted to make sure that we don't abstract away too much of what's happening on the underlying platform. The only thing that really changes is the language that you're writing it in, which to us was really powerful because we can build examples like the jelly slider built by Konrad Recko.
The jelly slider is really good, like killer demo.
It blew up in a day. We were really surprised. Surprised to see it, but the reception has been amazing. And the only negative comments that we saw was like, now my manager is going to make me implement this into my website.
It's 3D all over the web now.
Yes.
Just because
And if you want to see all of the errors in your application, you'll want to check out Sentry at sentry.io/syntax. You don't want a production application out there that, well, you have no visibility into in case something is blowing up and you might not even know it. So head on over to sentry.io/syntax. Again, we've been using this tool for a long time and it totally rules. All right. Yeah, I guess speaking of 3D, one of the comments that I got on my video when I talked about TypeGPU was wondering about how does this replace something like Three.js, or how does this fit into that ecosystem? Because I think a lot of people's introduction to any kind of graphics programming on the web for web developers might have been through React 3 Fiber or Three.js or anything like that. So do you want to maybe touch on how does this fit into that picture?
Yeah, of course. I mean, to us, TypeGPU was always meant to be a very succinct and small wrapper on top of WebGPU, and therefore we don't abstract. I mean, it's good that we don't abstract away too much, but also the users have to implement a lot from scratch. If you look at the jelly slider example, there's a lot of code that goes into it because we have to implement the rendering logic. It does ray marching, it does reflections and shadows. And because we write that ourselves, we're able to control every aspect of it and optimize around it, which is great. But for people that want to have just plop a 3D model on their website, Three.js is the way to go. I'm definitely not recommending you to build everything from scratch. But for those that want to delve deeper into optimizing and have that low-level control over what's actually happening, what code is running on the GPU, I can really recommend starting off from TypeGPU and learning that ecosystem. But I feel like TypeGPU still has a place alongside Three.js. We definitely don't want to replace and build a new Three.js from scratch. Three.js is an amazing ecosystem and has a lot of community support and resources out there. So what we're hoping is that the low-level building blocks built by libraries or by hobbyists that specialize in graphics programming can build them using TypeGPU and then hook them into Three.js. We have an upcoming Three.js integration. Hopefully by the time this interview is online, we would have released the 0.9 version of TypeGPU. And with it, we have a Three.js integration where you can replace any part of your material with a TypeGPU function.
Cool.
So let's say the lighting logic and everything is still handled by Three.js, but you just want to change the color of the material. You can just call from or to TSL, which is the node setup that Three.js has, pass in a TypeGPU function, and you have a TSL node that you can plug into your material. The same goes for compute shaders. If you want a way to write compute shaders in a more JavaScripty way, where you have if statements, for loops, and everything, you can do that. You can do to TSL, pass in a TypeGPU function .compute, and you're gonna have a compute shader working and interfacing with Three.js. So that's really exciting. It's been in the works for a while, and I'm really happy to see it come together. And hopefully, it's gonna make people more interested or have a feeling that they can do more with Three.js now, and delve deeper into those details and play around with them.
Yeah. I think TypeGPU will go a long ways to reducing just that. Man, every single time I've tried to learn WebGPU, there is just such a tremendous amount of dread that comes over you when you start to work in it. You're like, oh, this is I'm way out of my depth in this. So hopefully that reduces that. Because Three.js, things like that, React 3 Fiber, they're so approachable, but they're good introductions to wanting to get deeper with that. One thing that I really admire about your project is the documentation. The docs are really great. There's a lot of awesome examples. It's very readable and parsable, and you can get your hands dirty. For me, I'm like the type of person that really loves to get in there and tweak values and see what happens. What was the strategy there in developing docs? Was that always a thought, or is it just something that you personally like in documentation?
I feel like I've always liked writing about stuff, but it's definitely something that required a kind of a shift of a mindset. A little bit of background on TypeGPU. When it started, it did have a use case. I was building it for my master thesis, which involved doing super resolution of a game running in real time on the local user's machine. And I wanted to do it in the browser to just have a better time working with the GPU. And WebGPU was just coming up, and I was building up this API. So when TypeGPU, at least in its first form, before we were able to assemble a bigger team, it did have a use case of connecting different libraries together. But once we started working on it, we didn't really have a project or a product that we could use TypeGPU in. So there was no driving force to add APIs to TypeGPU that would help with a specific use case. So we were kind of we kind of needed to create our own product to have a use case for TypeGPU. And examples kind of became that. We were just like, okay, well, I want to do this using TypeGPU. So let's build this. What is missing? Okay, let's plug in these APIs. Let's create them. Okay, does this work fine? Okay, let's create another example. No, this doesn't generalize that much. Let's try to think it through. And I feel like we build a lot of these examples before we ship or stabilize features in TypeGPU, because we want to ensure that it's both fun to use and it works for those particular use cases. So that kind of came naturally, where when we shipped TypeGPU at first, we had a dozen examples or something right from the start, because we wanted to make sure that these APIs worked. And now they're kind of, they're cool to peruse around, but also when we introduce some breaking changes, they're great end-to-end tests, right? We want to ensure that we don't break anything. So we always run these examples when we change something and see if anything breaks. And as for the docs, we really wanted to explain how it works at first, but we kind of noticed that whenever we were describing a new API, when we were having a hard time explaining what it did, or it wasn't intuitive to explain, it was probably a wrong API. So it was very beneficial to try to explain it to both ourselves, the rest of the team, and to see if it's explainable in a paragraph, or if it's easy to learn step by step. And it led us to a lot of exploration of other things that maybe are easier to explain. And that's kind of the driving force. And I feel like docs are usually seen as this last step of like, oh,
right. Now I got to do the docs.
I wrote this and it works amazing, and now I have to write about it. And it takes time away from me actually building it. But I feel like in our case, when we did this mind shift of I want to build this cool thing, so I have to explain it to my teammates and like figure out what APIs I need, then it kind of comes naturally. And we're still pushing forward with that philosophy, I guess. So expect more examples. More examples to come.
A lot of people talk about GPU, WebGPU in general, being not just for graphics, but for interfacing with the GPU to do things like AI in browser. Is that a focus of TypeGPU at all, or is it just something that it enables?
Yeah, it definitely enables that. I mean, we're definitely trying to build out the ecosystem ourselves if we need it for, say, an example. Our main approach for like building use case specific stuff for TypeGPU is usually we create a couple of examples that might have this functionality, and we see what's shared between them. And that happened for the noise library that we have, which implements a lot of the basic like random functions and patterns that you can plop into your materials or shaders. And with AI, we have one example that does this. Mm-hmm. We have a MNIST digit inference, so we can draw a digit and it figures out what that digit is on your local GPU. And I feel like once we build out more examples that are using AI, we're going to see an abstraction emerge there that we can extract into a separate library. But we really want to make sure that TypeGPU itself doesn't maybe not get tainted, but like doesn't involve itself with the use cases that it can be used for. We really want it to be open for interpretation, I guess. So whenever we do build some use case specific stuff, we release it as a separate library. And at least to me, it might be useful for people wanting to create their own libraries that hook into this system, where they can look at the simpler libraries that build on top of TypeGPU and use it as a template for their own like code or even their own library if they want to create one. So it both ensures that our API of the core library is flexible enough so that we can build cool libraries on top of it and not have to wait for like a feature request for, hey, can you expose this API for us? Because we need to hook into that by restraining ourselves to only put the essentials and low-level stuff in the core library. And having to use that limited API set, we expose that same API to the end user. And I feel like that's very powerful for customizability and extendability. So yeah, answering the question directly, we are working on AI stuff, but every AI example is very involved, usually involves a lot of research around which model is best to use, or even training our own model, and coding the specific layers that need to be a part of it, since at least right now we have to build all of this stuff from scratch. So it's taking a while, but once we have a couple of these examples, we'll definitely look at giving people a better abstraction.
Cool.
That makes sense. It's cool to see how you've architected the library, because you import from standard library and like you've kind of separated these things out to their purpose use. So it makes sense that maybe if there's enough of a use case, there might be like TypeGPU AI or something like, but it's not included in the main package, but you can grab it if you need it. So we're getting pretty close to the end. Is there anything we haven't asked you that you want to say, or anything you'd like to tell the world?
Is there anything I'd like to tell the world? There's so much. Follow the Syntax podcast.
Oh, appreciate it. Thank you.
I listen to it every time on my way to work. It's an amazing way to catch up on all of the newest JS ecosystem news. And yeah, I'm really excited to get to work in the open source. I encourage everyone to try out TypeGPU and to contribute, to look at the docs and see if it's something that you'd like to dabble into. I feel like graphics and GPU stuff is having kind of a resurgence on the web. And it's exciting to be part of that wave and to hopefully make it better. make the ecosystem a bit more approachable.
Yeah, thank you for doing that, making it much more accessible for people like me, for sure.
Absolutely. Do we want to do sick picks?
Yeah, let's do sick picks.
Cool.
Okay.
Yeah, so sick picks for people who don't know is the part of the show where we talk about things that we enjoy and like. And Ivo, we kind of put you on the spot here.
I know.
Just ushered you up here.
I should have known.
So is there anything that you're really just enjoying in life? Could be anything.
Pierogis are great.
Yeah, yes.
If anybody is not into Polish food yet, try it and you will be. And go and come to Krakow. Krakow has an amazing tech space emerging. And if you come, let's hang out. Let's talk graphic stuff.
Nice.
Awesome.
Cool. Yeah.
Cool. So thank you so much for being on. Lastly, big shout out to JS Nation. Thank you for giving us the space and letting us use this to do this interview. This was great.
Yeah, it's been awesome. Thank you so much.